Welcome to the Corrosion channel. My name is احتشام زاده. I'm a researcher in the field of corrosion and protection of materials. Chapter 9, Section 11, Risk-Based Inspection. In this video, inspection optimization using RBI as a continuous improvement tool. The main reference elements of a risk-based inspection program, API RP 580. Using RBI for risk management includes 1. Identification of risk drivers. 2. Inspection optimization. And inspection optimization includes risk management through inspection, using RBI to establish plans and priorities. Other risk management examples. Identification of risk drivers and inspection optimization are addressed on video number E48 or Chapter 9, Section 10. In the present video, details on inspection optimization are reviewed. 2.1. Risk management through inspection. RBI should provide direction for a management decision-making process of prioritizing resources to help manage risk through the creation of effective inspection plans. Inspection influences the uncertainty of the risk associated with pressure equipment primarily by improving knowledge of deterioration state and predictability of the probability of failure. Although inspection does not reduce risk directly, it is a risk management activity provided of new information that may lead to risk reduction. Impending failure of pressure equipment is not avoided by inspection activities unless the inspection precipitates risk mitigation activities that change the probability of failure. In-service inspection is primarily concerned with the detection and monitoring of deterioration. The probability of failure due to such deterioration is a function of the following four factors. 1. Deterioration type and mechanism. 2. Rate of deterioration. 3. Likelihood of identifying and detecting deterioration and predicting future deterioration states with inspection techniques. 4. Tolerance of the equipment to the type of deterioration. 2.2. Using RBI to establish plans and priorities. The primary product of an RBI effort should be a risk-based management plan identifying the inspection activities required to address all the credible damage mechanisms for each equipment item evaluated under any related mitigation measures. RBI is a methodological process for identification of damage mechanisms to evaluate an equipment's current state based upon inspection and maintenance history. By reviewing credible damage mechanisms and equipment history, an inspection plan can be created whose rigor may depend on the equipment's risk. The inspection plan should describe the type, scope, and timing of inspection examination recommended. Ranking of the equipment by the unmitigated risk level allows owner-operators to assign priorities to the various inspection and/or examination tasks. The level of the unmitigated risk should be used to evaluate the urgency for performing the inspection. For risks considered to be unacceptable, that is above acceptable risk threshold, risk mitigating actions recommended to reduce the risk to acceptable levels should be created. What is the acceptable risk threshold? After the risk assessment has been performed and risk values plotted, the risk results can be reviewed against risk acceptance criteria. risk plots and matrices can be used to screen and initially identify higher, intermediate, and lower risk equipment items. The equipment can also be ranked, prioritized, according to its risk value in tabular form. Thresholds that divide the risk plot, matrix, or table into acceptable and unacceptable regions of risk can be developed. Consequence of failure, likelihood or probability of failure. Risk increases toward the upper right-hand corner. Low, medium, high, extreme. Risk and risk plot. Risk equals probability of failure times consequence of failure. An ISO risk line shows a constant risk level. In this figure, the POF and COF have been determined for 10 equipment items, and the results have been plotted in an ISO risk plot. The numbered points represent the risk associated with each equipment item. Acceptable risk threshold. An acceptable risk threshold defines the level of risk an organization or individual is willing to accept. It's a measure of acceptable variation around an objective reflecting the organization's risk appetite. This threshold indicates the level of risk deemed acceptable for a specific project or operation, and when exceeded, requires action to mitigate the risk. In this figure, 3 regions can be seen: broadly acceptable region, ALARP region, unacceptable region, low risk, high risk, upper criterion, lower criterion. ALARP stands for as low as reasonably practicable, a concept of minimization where that attributes such as risk can only be reduced to a certain minimum under current technology and with reasonable cost. In the unacceptable region, risk must be reduced except in extraordinary circumstances. In the ALARP region, tolerable only if risk reduction is impracticable or if its cost is grossly disproportionate to the improvement gained. Tolerable if cost of reduction would exceed the improvement. And in the broadly acceptable region, risk does not need to be reduced. The RBI analysis may show equipment items that do not exceed risk tolerances within the risk assessment time frame. For these equipment items, no further risk management actions are required within the analysis time frame provided the risk is below the acceptance criterion and the conditions and assumptions used are valid throughout the time frame. 2.3. Other risk management examples. Some risks cannot be adequately managed by inspection alone. The following are a few examples where inspection may not be sufficient to manage risk to acceptable levels are as follows. A. Equipment nearing end of service life. B. Failure mechanisms such as brittle fracture, fatigue, where avoidance of failure primarily depends on design and operating within a defined pressure-temperature envelope, and C. Consequence-dominated risks. In such cases, mitigation actions such as equipment repair, replacement, or upgrade, equipment redesign, or maintenance of strict controls on operating conditions may be the only appropriate measures that can be taken to reduce risk to acceptable levels. Using RBI as a continuous improvement tool. RBI is a vehicle for continuously improving the inspection of facilities and systematically reducing the risk associated with pressure boundary failures. As new data such as inspection results and industry experiences with similar processes becomes available, or when changes occur, for example operating conditions, a reassessment of the RBI program shall be made that will provide a refreshed, updated view of the risks. Risk-based management plans shall be adjusted as needed based upon triggers that require an RBI assessment to be updated. RBI offers the added advantage of identifying gaps or shortcomings in the effectiveness of commercially available inspection technologies and applications. In cases where inspection technology cannot adequately and/or cost-effectively reduce uncertainty and therefore calculate risk, other risk mitigation approaches such as monitoring IOWs can be implemented. Integrity operating windows or IOWs are establish limits for process variables or parameters that can affect the integrity of the equipment if the process operation deviates from the established limits for a predetermined amount of time. Challenge number 50. Thank you for your time and attention. If you'd like to challenge yourself, please answer these questions in the comments below. 1. Who defines the acceptable risk threshold? 2. RBI can be used to establish plans and priorities for inspection. How? 3. What approaches can be implemented where inspection technology cannot adequately reduce uncertainty and therefore accurately calculate risk?